Okay, I want to take a few minutes to explain this small program. Your final exam will have something similar as part of it to this. So I want to make sure that you kind of understand how to attack the problem and then what all these parts mean. So here it says create a procedure named calc grade that receives an integer value between 0 and 100 in the EAX register. What that means is that whatever you assign to the EAX register, you're going to assign it before you call the procedure calc grade. So this part right here would look like this. Here in main, I would move the value to EAX, like a grade like 75. And then I would call the procedure calc grade, which I haven't made yet. But that's what it means to pass the value to it. So it means that you're not moving the 75 inside the procedure, you move it before you call the procedure. And then it says that this procedure will return a single capital letter in the AL register. You're going to display the grade in EAX and the letter AL. Since AL is getting returned, what that means is that inside calc grade, so when you create calc grade, let's make this bigger. And calc grade and procedure. So anytime I make a procedure, there's three things I do. I, of course, give it the header and close it, and then I put my RET. If you don't put RET here, when you run your program, you're going to get an exception. So if you get an exception, then that means that you forgot RET most likely. Because remember, RET pops off it does a pop from the stack, the runtime stack. And what's getting popped off is the address to where to return. So at this point, after you call calc grade, it returns to this instruction here to exit. So returning returning the grade in the AL register means that here inside the procedure, you're going to do a move into AL and you're going to move a letter, right? Like A, B, C, D, or F. And it's going to be dependent on this grade. And because it's getting returned to main, right? It's getting returned where the procedure is called, you would do the write char here, call write char. So right now, if I run this, it's always going to move an A into AL. It's going to return. It's always going to write char an A, which is good. I'm going to just show you what that looks like. So write char uses the AL register. That's how write char works, is that you have to have the character in the AL register. And write decimal, this procedure uses the EAX register. So that's why they asked you to put it in these registers, because they know that these are the registers that these Irvine libraries use. Even though we could have used DBX, BL, AH, etc., we don't want to, because we want to call these procedures. So when you run this program, it will go into main first, right? It's going to move 75 to EAX. It's going to write that 75 to the screen. It's going to call calc grade. It's going to jump here to calc grade. It's going to move the A to AL. And when it returns, it's going to return to this instruction. And that instruction, right char, will output the A to the screen. CRLF means new line. So this gives us a new line. We'll see a new line, and then we exit. So remember that RET does a pop. And what it's popping is the return address. Oops. Pops return address. So where to return to. This call right here, call calc grade, pushes this address of where to return to. So call calc grade will push the address of the next instruction, and return will pop it off so it knows how to get back. So let's go ahead and run it. And right now, what you're going to see is 75 and A. So 75 is this number that I put into the EAX register, and A is this character right here that I moved into AL. And there's no space between 75 and A because I haven't added a space. So what I'm going to do is I'm going to put it on separate lines. So I'm going to do a little bit of formatting, and I'm going to use write string to format. This line right here, in the lab, we're getting that virus issue. And in the lab, we cannot change the security paths, the security settings. So we just add that there to make sure that we never get that virus error. Okay, so what I'm going to do is I'm going to create a string. This is going to be what I put before I show the grade. So I want to see grade and then the number 75 next to it. And then you do have to have this end of string. It's really important. If you don't have this end of string, it will grab the next string also when you do it write string. So right here before I show my right decimal, I'm going to move into EDX. So EDX is a register that write string uses. So I'm going to move the offset of the string. I'm going to call it string 1. And then I'm going to call write string. So write string uses the EDX register. And how do I know that? It's in your book. I read it in your book. So if you go in your book, it will tell you all the registers that each procedure uses, and it gives you examples. So that's the only way to know. So this here will move the address of the G, like where G is in memory, it moves it to EDX. And then write string prints out everything until it reaches the end of the string. So it will print out grade and the 75 after. And then what I want to do next is print out or show letter. I'm going to do string 2 byte letter. And then make sure you have end of string, otherwise it will cause problems. So then here, before I do a write char, I'm going to do the same thing. I'm going to move to EDX, the offset of string 2, and then call write string. Oh, and I need a new line. So right now it's all in one line. So I'm going to put a new line after the 75 before I put the word letter. If I didn't want to put a new line, I could put some spacing here. So I have some spacing right there, and that would look good also. That doesn't look bad. So you could do that. I kind of like that better. Or you could just put, so right here after write string, we could do a new line. Okay. All right, so we've got it formatted. It looks pretty. This is what I would do if I have an exam, right? And I've got to do this. I would at least make it work. Print out the decimal number, print out the letter. Everything you do gets a certain number of points. We've got a procedure that gives you a certain number of points. Now I've got to do the comparison, do that if statement. So if it's greater than 89, then I know that it's a letter A. So this part that I'm about to do can be done several different ways. So this is not the only way because there are different jumps. So you can say like, is it greater than 89? Is it greater than or equal to 90? Yeah, and you could say like, is it, I think those would be the two that people would use the most. So I'm going to do a compare first. So CMP, and what I'm comparing is EAX, and I'm going to say greater than 89. So once you compare, the way that compare works is that it takes what's in EAX, so like that 75, and it does this. It does a subtract. So it does a 75 minus 89. That's how all if statements comparisons work. We're just subtracting. So when you subtract 89 from 75, what happens is that the control flag will get set because, not the control flag, excuse me, the carry flag. The carry flag gets set because if you try to take 89 from 75, you have to borrow. So that carry flag is gonna get set. And so you could either do a JC. JC would mean that this number is not greater than 89, or we can jump if EAX is greater than 89. I'm gonna do that one. That one's, I like it better. So if EAX is bigger, EAX and 89 are unsigned numbers, so I'm gonna have to use the JA. So jump if EAX is after, this is how I remember, okay? So if EAX is after 89, 90, 91, 92, etc., then I know that it's a grade of A. So I'm going to jump to a label called grade A. Your compares need to be all together. Your labels need to be all together, and I'll show you why in just a second. So my labels are going to be down here. So here's my label for grade A. And it just moves A to AL, and that's it. So that does the comparison if it's greater than 89. So let's go ahead and put, now here's the thing with the way that jumps work that I wanted to really show you. So if this is false, if the number like now, right now, 75 is not greater than 89, if it's false, it will skip this line. It will not do JA, right? But it still goes to this line right here. No matter what the number is, so let's run it. So no matter what, it's printing that A right there, because what it does is it compares, it's not greater than 89 because it's a 75. So it doesn't jump. So it goes to the next line. The next line is a label. Labels don't prevent you from entering the label. Okay, so labels do not prevent you from entering the label. So I'm going to have a jump here or have another compare. I'm going to have a compare. So basically what I'm going to say, okay, well, if it's not greater than 89, then let me compare it with 79. Is it greater than 79? If it is, then I'm going to jump after, not 79, sorry. Yeah, 79. That would be grade B, the jump to grade B. And this is grade B. Grade B moves into AL, the letter B. Now, if it's an A and I jump to here, it's going to move A to AL, and then it's going to move the B to AL. Because again, this line, so let me show you, it's going to be a B no matter what. So the number 75. So 75, let me do a different letter. So let's do an A. Do 95. Okay, so 95 is A. So we give it a 95. 95 is greater than 89, so it jumps to A. So it jumps here to A, and it moves the A to AL, but then it goes down to this next label, grade B. Again, that label doesn't prevent it from going inside, it goes into here. So what I need is, once I assign that A to AL, I need to be done. And so I'm going to do just a regular jump that jumps to a label called done. And what does done do? Well, done just returns me back because I'm actually done. So let me show you now how this works. So now I've got 95 and the letter A. So again, it's a 95. 95 compares it to 89. It's greater than 89. So it says jump if 95 is after 89. It is. So it jumps to A, label A. It does what's in label A, moves the A to AL, and then jumps to done. Here's done, and it returns. Okay. So I'm going to put the rest of my compares. So this will be 69. And that means that I'm at grade C. So here I'm going to jump to done. If it's a grade B. And if it's a grade C, I'm going to move to AL letter C. Now, let's say that C was the last letter. Okay, let's say that I just had to do A, B, C. If all I had to do was A and B and C, I don't have to jump to done, because once it moves C to AL, it goes to done automatically. So I don't have to jump to done. I can leave that out. So right now my program works for A, B, and C. And so I can test it for B. So I can test like let's test an 80. And then we're going to run it again. Test a 70. That's all I have implemented right now. So there's a C. Okay. I wanted to show you one more thing, which I did in the on-campus classes. So again, this works for one letter grade. Let's say that what I asked you to do was to create an array. I asked you to do the same thing, but what I wanted you to do is create an array of grades. And right now I'm going to put just A, B, C, since that's all I've done. Okay, with these grades. And what I want you to do is loop through this array and print 95A, 80B, 77C, 70C, 100A. Again, if this is a test, you just do it for one. Make sure you can do it for one. Don't ever just start putting loops and just expect everything to work perfectly. Make it work for one. Once it works for one grade, then we can make it work for an array. So at this point where you're moving 70 to EAX, you want to move each of these into EAX. That's where the loop comes in. There are several ways to do this. I'm going to do it using an indirect addressing. Indirect addressing is this right here, using offset. So the first thing I'm going to do is when I do a loop, I've got to set my ECX always, first thing we want to do. So ECX is going to be length of array 1. So that gives me ECX will be 1, 2, 3, 4, 5. And then I'm going to call this loop 1. To indent just because I want it to look nice and readable. Oh, so right now I have this loop and hopefully it will iterate 5 times. I'm not going to do anything here. I'm just going to test. Did I do my loop correctly? Does it iterate 5 times? It should say 70C 5 times. So 1, 2, 3, 4, 5. There we go. 5 times. Again, this is how you go about doing a test, okay? Little bit at a time. Okay, so now that I know that my loop works, I'm going to try to put these numbers into EAX. So by doing indirect addressing, I'm going to use ESI, and what I'm going to move is the offset of array 1. So ESI is going to contain the address of the 95. So here, instead of having a 70, ESI is the address. ESI contains the address of the grade 95 because that's the first element in my array, right? So I'm not going to put ESI here. I'm going to put brackets. I'm going to dereference ESI. The brackets, what that does is it grabs the value that the address holds. So that's called dereferencing the address. So right now, this 95 is going to get put into EAX. And I'm going to test it. And look at that. I see 95 5 times. So I know that I got the 95. So now I've got to get to the next number, to the 80. To get to the 80, I have to add to ESI. And I've got to add 4 bytes to get to the 80. So I'm going to do it down here before I loop back again. I'm going to add the ESI 4 bytes. So I could do 4. I can hard code 4, but I'm not. I'm going to use type and then the name of the array. So type will get the number of bytes of array 1. So array 1 is going to get this type right here. So if you put a byte there, it's going to get a 1. If you put a word, it's going to get a 2. Double word is going to get a 4. So it's going to add 4 to ESI. When it loops back around, now I'm at the 80, and it's going to move the 80 into EAX. So I'm gonna look at here, I got 95, it's an A, 80 is a B, 77 is a C, C, A. Again, you didn't see me type everything at once and then try to compile and run. You saw me do little tiny bits, making sure that I don't confuse myself, that I just do each little step and get as many points as I can. Let me see what else I wanted to show you on this. So the other thing that it says is to preserve all the other register values between the calls to the procedure. So to preserve the register values, you would have to do the following. Where's my procedure? Here's the calc procedure. So the registers, all other registers. So that would be, you would have to push not EAX, you don't want to push EAX, EBX, CX, A, B, C, D. So there's 4 general purpose registers, A, B, C, D, EAX, EBX, CCX, CDX. And then there's ESI, push that one. We don't ever mess with EBP or the other registers. So these are the only other registers that are being used. So you could do that. This is called preserving the values. That means that if for some reason in here, you decide to use any of these registers other than EAX, you would restore them before you leave. So this is where you leave right here. So you would restore them by popping them in the correct order. So we have to pop them. We have to pop ESI first, then EDX, so it backwards from what you pushed. ECX, EX. So I'm just checking that I'm doing it backwards. Yeah. So this is preserving the registers. Most likely, they will tell you, you know, what to preserve. Another way that you could do it is, so you could push and pop, or you could say uses EBX, no comma, ECX, EX, ESI, like that. Now we're not using these registers, which is why really there's nothing else. Like this procedure is not messing with any registers that you need here. So you don't really have to, but this will preserve the register. So if for some reason you decide to use EBX here, it would keep the value of EBX up here, which we're not even using. We're using ESI, so it would, if for some reason you use ESI here, it would preserve this value of ESI. So there you go. Okay, that's all I had that I wanted to show you for this exercise. Please make sure that you are able to code this, practice, think of other examples that you might be able to do that use compare and jumps. And the main thing to remember is that a label does not prevent you from entering this piece of code. So that's why we have to jump once we're done with a block of code. It's almost like a closed curly brace. Compare always does a subtract. So if you subtract, let's say that you're comparing to 89, like 89 minus 89, this would give you a 0. So it sets the 0 flag. That means that if you wanted to see if EAX was equal to 89, you could say if JZ, jump if 0, or JE, jump if equal, either one. JE also looks at the 0 flag. So you have different jumps available. In high level languages is exactly the same thing. So if you're saying is 89 equal to 89, it is doing a subtract. It will subtract 89 from 89, set the 0 flag. If the 0 flag is set, it will be true. Okay. All right, guys. Thank you. Email me if you have any questions.